Who's coding Java on a regular base every day? 1, 2, 3, 4. Project management? Okay. Good. We are talking about Java, nothing else. So, everything I'm saying here is more or less from Java 8 up to whatever is coming soon. 13, 14. And my name is Sven. So I'm working for Vardin. Who knows Vardin? Hey, come on. We are here at Library. A little bit more. Okay, so this Finnish company that will build all these Lego bricks for the web development. But I'm earning Java, my money with Java since 1996. So if someone is asking here why it's done different in C#, I have no clue. I can't give an answer. I don't know. Never learned something more. So I'm more or less on the server side. So I'm working in distributed systems, or was working in distributed systems quite a long time, and mostly in consultancy projects worldwide. That means everything what I'm saying right now is influenced exactly by this stuff what I have seen. So there's multi-million lines of code. A bunch of consultings are jumping in, jumping out. Every few years a new paradigm is quite fancy, cool, whatever. And this is running over a long time. So this is where I mostly was working in. And yeah, by the way, out there, the name is changed from Developer Champion to Groundbreakers. The main thing is I was working in this environment. Okay, that means someone else is working in space, defense, military, automotive, health, insurance, banks. Everything's the same. Yeah? So you can feel my pain. Okay, so. And then after some time, it was always a disaster to introduce new libraries, because the legal department was there and says, oh, you want to have this, whatever dependencies. And then after half a year, you got this one, and then it was just old. And then it says, okay, please, new version. And they says, no. Then you have the whole process again. So what I'm mostly doing is I'm trying to get rid of all dependencies. Before 8 and 9, everybody was laughing. Now, with this faster release cycles, I'm smiling again. What a surprise, huh? And so I'm focusing on bringing stuff back to the core JDK. Okay, and this is what we are right now talking. Long time ago, they told me object-oriented design pattern is the best what I can do. And do you know that there is a book about object-oriented assembler? Yeah, it is available. But now everything is functional. Who is coding functional? Okay, the rest will be addicted after my talk. Good. So, but the main question here is, if you have these functional things, any one of you at the university lecturing some stuff? Good. Well, it's not a shame. But I have only one disclaimer. Okay, the main thing is, I'm talking about functional whatever. Whenever I'm talking about functional, and then I must be very, like a consultant, it depends, maybe, and all this stuff, so never say something concrete, because mostly the guys from the university say, oh, the definition of function, and then I'm hearing a long story and start sleeping. So I'm, since this, just talking about functional aspects, okay? That is why I'm choosing this one. So, okay, we have this optional. Optional is quite nice. So, if I have something that's holding something and have a method where I can put this stuff here, this lambda expression, is this functional? Who says yes? Who says no? The best answer is it depends. Huh? So, the next thing is, if I have something, say, okay, if here's something, or else throw, and I can put some lambda expressions here, functional, yes, no. So I have a value, I'm putting some behavior from outside here. The next thing is, if you are doing this one here, everybody knows what's this here? Double point, it's not Perl, it's not, it's a method reference. Okay, so is this functional? And the next thing is, if I'm doing all this stuff again with this old syntactical thing, now it's object-oriented, no? It's clear. So the main thing is, we are not talking about only this syntactical stuff. This will help to have it in a compact way. But what we are talking about, you can do with pre-Java 8. It will look a little bit different. With lambdas It's just a little bit nicer. But the main outcome is object-oriented functional programming. Java is an object-oriented language, and we can have some functional aspects, but there is not a pure functional whatever thing like at the university. Okay? So, the main thing, functional interfaces. One thing, only as a warm-up, this is a functional interface, yes or no? Okay, do I need this annotation for this? Yes or no? Everybody must say no, no. Why is this useful, this annotation? Because you have colleagues. Why? If you start doing here this stuff and someone else will add a method, then it's not a functional interface and all your funny API is broken. Huh? Okay, so is this a functional interface? Yes or no? Yes. Okay. And this one is the default implementation. That means the definition of a functional interface is only one method that must be implemented. For everything else, we have a default implementation. Fine. So we can play with this Lambda stuff. You will see why I'm doing this. This one. I have different interfaces and different implementations. So, coming here. The first one here. First of all, I have an interface A with a method do something and a default implementation. Is this a functional interface? No. Why? There's nothing to implement. For everything there is an implementation. Okay? Good. Now I have an interface B, extends interface A. Functional interface? No. The default implementation is here. What's a winning implementation here? I've now, in my inheritance, 2 times the same method and 2 times in default implementation. What's a winning implementation? Which one will be chosen by, if you use this one? I will come back. Okay. Here it's quite easy. Inheritance, 1 line. Well, if you're using interface A and implement this one, this default implementation is winning, otherwise this one, huh? Okay, if you're using this one. Okay, now we are coming to things that are quite fancy these days, no? Going out of inheritance, going to composition. I have an interface C with a method do something and a default implementation. So far, everything fine, huh? But what happens now? I have a class A, implements interface A and B. Is this a valid implementation? Who says yes? Who says no? Oh my God. Don't let it seep from your management. It is a valid implementation. Because for every method you have an implementation. There's nothing to implement. That's right. Which one will be chosen from do something? B, huh? It's most specific. This one or this winning implementation. But now I'm doing this one. I have a class B, interface A and C will be implemented. Is this a valid implementation? Yes, it is, but what's the special thing here? The compiler will immediately break and say, hey, wait, you have 2 methods with the same signature on the same inheritance level and both times the default implementation. It means there is no way to decide which one is the leading one. So you have to do it by yourself, you have to implement and whatever. Here I'm just using this one. Okay? Why this is important? This is important. Why? If you're going to functional means going to the limit in terms of abstraction. That means your wording will be more and more generic. More and more generic means that you will have maybe the same idea to give the same name for the same method or whatever, but have totally different things in your head. Then you say, okay, I have this functional interfaces here in your package and you one in some other packages. And the developer somewhere says, I need this one and that one, or this one and that one. Huh? And now you have an overlapping in terms of naming, method signatures and all this stuff. And this happens because the naming, if you're going to more and more generic things, are more and more the same. Okay? So have in mind how to deal with these default implementations and these functional interfaces. One tiny question. If I say my class A, and I say class A dot do more is this static method here. Can I invoke it like this? Who says yes? Who says no? Nobody says anymore. It's not. Forget it. You have to do it like this. Interface A dot do more. And this is a pain. If you're designing, we will see why we need this static method in interfaces later. But if you're doing this one, you're exposing details from your API. If you have some inheritance tree and want to expose an API, if you want to have this method, you need exactly this one. You can't go over the last in your inheritance tree. Okay? Have it in mind. If you're designing APIs, this will happen. Okay. So, and this is more or less what we have done. And the outcome, it's just verifying which one is a leading one. One interesting thing is that after Java 9, we have not only this functional interface, we have the possibility to implement private methods in interfaces. Means default implementation could now design a little bit more as we are used to it. Not only one big method, we can now make smaller methods out of it. And the same is, I can have private static methods. Only as a reminder. Okay. Optional. Optional is quite nice, and it's the first way to go a little bit to the functional world. It means an optional is a holder. We love null. Who loves null? I know, you are coding Kotlin. So, over the years, we have this null object pattern, and then finally we have it inside the JDK, this optional. What we can define, we can say there's an empty one with a predefined value or maybe null. Okay, but we have a holder, and on this holder, by the way, this holder is typed somehow. And then we can say, okay, ask if it is present, get or stream it since Java 9, so grab this value out. But what's way more interesting, that we can work on this holder. We are not grabbing this value out, we just say if there's something, do something. For example, if you have something present, do something, otherwise do something else. I have the possibility of a decision, left or right. First thing, okay. I can say if there's something, otherwise give a default value. Some kind of decision we have. This throwing, I don't like it, but it's there. But there's one thing, oh, by the way, and you can start transforming. That means you're not grabbing value out, you only say there is some kind of transformation. I have this value and I give my transformation to this value, and this will be again an optional. So we are not grabbing a value out, we're holding it inside this optional. We are not dealing with nulls somehow, and we can do stuff. Mapping with method references and yeah, all this stuff. So there's one thing that is, yeah, this one is since JDK 10, you can throw in some stuff, but don't focus on it. The main thing here with this optional is, it's final. Final means you can't extend it, but the optional has some limitations. It's not symmetric, for example. That means you have something like is present, but not if absent. It makes code ugly. You have only blocking calls. You don't have non-blocking calls. If you want to have something non-blocking, you first have to grab this stuff out, wrap it in complete future. Even this is not nice. I think it's not functional enough, but we will talk about this a little bit later. This defined or declared final we had, so we can't extend it. The only thing is that if I want to do something, I want to extend, I need something written by myself. I know with Kotlin. So the main thing here is, if I want to extend this one, a holder, so that I can deal around this null thing, I need to implement something by myself. I called it result, you can call it whatever. One thing have in mind, it must be easy to transform between optional and your implementation, so that you have, in best case, something like a drop-in replacement, or later you can just say search replace, if maybe the optional will give exactly the signature you wanted to provide. We don't know what's going on with an optional in the next JDK versions. Okay? So, then it should be somehow a connection to the reactive world. We have completed future. This is quite cool stuff. We have a look a little bit there, what's going on there. But it should be symmetric. Have in mind that your API should be used in it is available, it is not available. So that you don't have this negation. And if you're starting implementing functional stuff, you have colleagues and maybe they don't like this functional stuff, so make it usable not only for the functional way, make it usable for the object-oriented way as well. Otherwise you have something like Scala, an ugly wraparound, and then you're using it in a legacy project. Perfect. So how it should look like: to optional, from optional, only for conversion, and then, and this is something interesting, and this is the first improvement. I know if I have a result, for example with a value, it's typed here of type string, an optional of type null or empty, what is the type of it? And what is the reason why it is null? We want to have the information later. Here I can say I have a failure, and I can give some information with, but the typing is the original one. Okay? Only have it in mind. We need the information why something is going wrong. If I have just an empty optional, this information is lost. But I want to be in the same typing. So, the next thing is if absent, if present, stuff like this, or the decision, including success or failure. We have it more or less with optional now, but the next thing is here. Easily, if you're creating an API, the blocking and the non-blocking world, just have a look at this complete future. They have done it a little bit right. Don't use completely different names, just use the same name with an asynchronously behind. Okay, so slowly we have a few things together we need. Then the interesting thing is you can't only have a, or if you have an optional and you have another optional, mostly it ends up that you're grabbing both value out, transforming it, and putting it back to an optional. And this is not nice. If you have a holder, stay in the holder. How to combine? You can combine with, again, stolen from complete future, with something that should be happen here, the transformation, based on the value from the result and the next one. Okay? Start combining values. And this could be done in the same way asynchronously, while waiting. And the next thing is, and now we are coming slowly to the functional stuff. If you're thinking about a value, you can combine values, but later you can say, okay, I can combine functions in the same way. Because a function is nothing else as an instance. So I can combine a value with a function with a function, and so on. Even this should be possible. I have here my function that I start to combine with a value. Here at this point. No? I have a value and a function, and the result will be the invocation of the function itself. Slow preparation. Now I can only hold values. Okay? I have to make a little bit hurry, otherwise we are not fast enough. So, exceptions. Who loves exceptions? Checked one, unchecked one, yeah. So, mostly if you see something like this, you have this try catch. You have here something, you're parsing, and this will throw an exception, number format exception. Good. Now we are working with streams. We have the values 1, 2, 3, something, and so on, and I want to convert. Is this good? Maybe. So, reading documentation somewhere, it will lead you to something like this. What are the bad things here? A few things are just bad. First of all, I have this try catch. If I have more than one mapping thing, then this is repetitive. The next one is, I'm returning something, and this is part of the possible values. It's not nice. So the first improvement could be something like this. You have an optional. If it is running well, you have this optional. If it is not running well, you have an empty one. Then you check if it's present, grab the value out. Is this nice? With JDK 9 you can write a little bit different. You can say, okay, stream. But it's just not nice. You have here different challenges. You have no information about what's going wrong. This information is lost. And this try catch is just repetitive. It's the pattern that we should extract. Okay, let's assume we have something like this. I have a stream with some values and I have a checked function. The checked function will do something, and it could have an exception, or it could throw an exception. Okay? And then I can work on this one. I can write this a little bit more in a less syntactical or in not object-oriented way, but in this functional way, but how to write something that can deal with my exceptions. It's not so difficult, because having in mind what is a functional interface? A functional interface is an interface that needs only one method that should be implemented. The other one has a default implementation. If I have a function and I have a default implementation for apply, then I can define an apply with exception without implementation. What I can do here is just that I have, and the next thing is I have to implicit wrap this type. I can say from string to int, but in the end it means something like string to holder of integer, because I need something to give this information that something was going wrong to the next step. So a function from T to result of R have a default implementation for apply. Now I'm extracting this try-catch stuff, because this is always the same, and I have only to implement this one that's throwing an exception. What I have here is now the easy way to extract try-catch. Now we are going slowly to the functional world, because we are pushing abstraction to the limit. Everything that I can describe in a more generic way will help to go to this. Okay, what I have here now, with this checked function, I have in the same time something like a checked consumer, because the checked consumer is nothing else as a checked function from T to void, plus the information what's going wrong. And I have a checked executor. It's from void to result of void. Even this is done. And I have a checked supplier, because it's just a supplier of result of something. Everything is done in the same way. So I have all this stuff. Now I can deal with exceptions. In a functional approach, what I want to do is I'm catching all exceptions, but I'm not throwing exceptions. Something what you can read quite often. So how to deal with this? And don't use null. So function basics. We have here a function int to int. Great. What does it mean? It's just a transformation from A to B. Let's see. This is an approach I see quite often if you're object-oriented trained. It means I have a function, and then I'm applying, and then I start chaining this one. This is nice. You can see that this guy is definitely object-oriented trained, because he's producing some result, he's grabbing the value out, doing this in different steps, and then start chaining all this stuff. Okay, we can do something. Let's start. There is a possibility to compose functions. It means what I'm doing here is I say I have a transformation from A to B and from B to C. What I can do now, I can make one transformation from A to C out of it without dealing with values. The value is only the invocation later of the final function. Okay, what happened here? If you're dealing with this typing stuff in Java, you have some challenges. You can't write with compose this one here, +10 +5. You have to write it with the full type here. Why? The type interferencer in Java will say there is something that comes from some type, will do something, and this type that comes out should fit to my one that I do, that I can consume. And the type interferencer is not able to look so many steps ahead. So what I want to show now is nothing for production, please. Okay, it's only to play a little bit around. If you want to have the possibility to deal with this type so that you can write something like this, it will end up in this here. Clear? This is a higher compose, fully typed, and it's nice. It's more or less only an invocation of different functions in the right order. But the challenge is, if you're going this way or with this way, then you have the challenge that with these methods and all this generic stuff here in front of the invocation, by the way, it's clear, only to read it. I have a function that can transform a function from int to int to a function that is possible to transform a function from int to int to a function from int to int. It's clear, huh? how to make this generic. How to use this. The main thing is here, what we achieved with this, the typing information is now available. But the price is that for the invocation of this static method, you have to put all the type information in front of. So this way of composing function is not good in Java. But it depends on this type interferencer, okay? So we have to find another way. And please, if you start designing API, have in mind that both of these ways are just too much to write. What we want to do is more or less that we going the other way around. I say not compose, putting something on before my function. I chaining functions that I say, if I'm done, then do the next step. And the type interferencer is quite easy to handle this one. For example, if you're going with and then instead before or compose, then all information is here because the input type for the next step is based on the output type that is already existing. So if you're going to the functional way, work always with and then instead of compose. If you're reading books, mostly they're going completely the opposite way. I don't know why. But we had this one here. If I have this instance of a function ABC, then here all type information is available. I can write this compose. Okay, because everything is fully typed. And then in the same way. But the main question, even if I'm playing around with this stuff, is how to get this instance. And what's the right way to define it? Because this is fully typed, I can't play with generics, this is no help. Functions, a definition of a function must be more or less typeless. It must be typed during the invocation. So, the first thing what we could do, and now we are back to these interfaces with these static methods, it's a good place in interfaces to have these static methods that will give you an instance of a function. Here, only to make it easy, I have 3 static methods. They are fully typed. Here, only with integer, not with generic so far. And then I can use compose without any problems. And then. Okay. The next step is, if I know what's the right place in interface with static methods, because interface I can put everywhere together, and the static methods I can invoke with static imports very, very nicely, how to make this one more generic. Okay? So, the next thing is, if I have now this plus 10, plus 5, plus whatever, I need the possibility to make a generic adder. So if I'm writing down a function only for my needs I have right now, this is mostly not generic enough. Here in our case this function plus 5, 10 and so on, I wrote down and it's not reusable. What I need is a generic adder instead of fully specialized adder. And it means I have something, a function, that will give me, based on the input value, here is scalar, an int, a function that will give me an int to int, but adding exactly what I used as definition before. And so I have here this chain function, and I can say now, I have the possibility to add constantly 10, 5, or whatever. Okay? Going a little bit more to abstraction. And then I can use this stuff again with and then compose or dynamically. So now I have the first step to make functions more generic instead of writing exactly what I need. Describe how to get it. And this is a big thing you have to change in here. Don't write down what you need, write down how to get it. Okay? So, and then it would lead you to some adder, and then you can use this adder one. But, let's see. There's this list, and you're filtering here, and want to print it out. And the next one, you want to filter not for I, you want to filter for G. Okay? So, how much of this code is double? 2 times written. 99%, huh? The only difference here is this input value. And if you're going first with your IDE to this, like you've done it in an object-oriented way, it will lead you to some, yeah, not really usable stuff. For example, extract consumer. Okay, could be done. Then I have somewhere this variable, and I start extracting, extract thing, this predicate. Is this okay? Would this help? Not really, no? If I'm writing down this one, stream filter with my predicate for each print line, and doing the same stuff here, this is a challenge. If I'm writing down or extracting with an IDE like this, it will lead me in the end, if I'm going through the whole chain, to something that must be final. So this values, or functions, or whatever. So there is no win, because I'm writing more or less the same stuff. I can't use it here. So I have to find a way how to describe what I want to have, but getting rid of these final definitions. The main thing is here that you're going here to describe how to create what you need. Again, describe what you, describe how to get it, not describe what you need. And here, my description is, from an input string, I want to create a predicate for this. And now I'm dealing the first time with higher order functions, because I'm creating functions instead of values. But an instance of a function is nothing else as a value. You can, okay? And if you have this one, you can start creating functions that can create functions and so on. So if you solve this for the first level, you have a solution for all upper levels as well. And then it would be something like this, this predicate, and the only change here is this one. So you can write this once, and the input value will change per invocation. Now I have extracted the repetitive part. Okay? So, mostly, it ends up in currying. Currying is something you heard last time at the university, or? Who knows what currying is? Okay, for the rest, good luck. I have a by function. Why I need, so pure functional is one input value to one output value. It's only one thing. This is a pure functional way. But we have to deal with legacy code. It means we have methods with more than one input value, and it leads more or less to this way of, I have a by function, two input values, one output function. Now I have to find a way how to make out of this a function with only one input value and one output value. Otherwise, the theoretical part of the functional world is just disappearing. So, what it means is, I have to transform this by function in a way that I can partially invoke a function. I have a function with the first input param that will give me a function that needs a second one to give me the result. Okay? Good. How to do it in Java? I have a function that will transform my by function to a current function. Easy so far. And this is the result. Sure? Everything's fine, huh? What so far? I have a function that will transform a by function to a function from A to a function to B of R. Okay, so the only thing that I can see here is I have something that will be applied with two input values. The only thing is that I have two steps now. The first value will give me only the first transformation. Okay, so the main thing is, what can I do with this? Okay, let's see. So if I'm writing this a little bit more compact, I have my transformation, and this is in a generic way, the description of how to transform a by function to a function. The next thing is, if I'm writing it more compact, this one, you get used to this style of things somehow. And we are back to per. So, if I have this one, I can make a static method out of it, called curry by function. Okay, now I can give me at runtime a generic version of this transformation. It will give me this function that I can invoke. But if I can do it in this way, I can go back. I can curry and I can uncurry. Why should I use this one? For what is this useful? The main thing is I can transform functions from by function to function. It means in the end I have a solution for level n to n-1. This means I can do it for all levels, for try function, quad function, and so on. And I can go reverse. No bytecode manipulation, nothing. Oh? Okay. It means if I need something for 3 input values, I create a try function, exactly like a by function is defined in the core JDK. So maybe we have someday a try function, so you can get rid of this one with an and then, and so on. Oh? And then I can do exactly the same. I can query a try function and I can unquery a try function, because it's just the invocation of one more dimension. Good. If you have solved the challenge for a function, the next one is for a by function. If you have done this one, there's no limitation anymore. This we need. For example, if you have memoizing. Memoizing means, or a function means, a function, if you say, I invoke my function with 2 and 1 is a result, I'm doing this twice, this 1 will be always the same. Okay, now I have a function that will give me an instance of a car. I invoke it 2 times. Now I have 2 instances of a car. Same, not, same identity, or only the same values. If I want to have this pure functional behavior, it must be the same identity. Okay? And this we can do in terms, or this is more or less caching on method or caching on function level. For this I need only a concurrent hash map, and what I'm doing here, check for an input and a function and compute the output. Means if I have the function, I get once this input, it will calculate with this function and store it. The next time I will get the same input, it will just give you back the already calculated stuff, otherwise it will create the next value. Okay? Now we have memoizing. Good. And this I can do with a function from T to U. And it means everything that I can transform to a function, even a by function, I can start now with memoizing. Memoizing is nothing else as caching. Okay, let's see how it works. We can go now with a by function, and what we are doing exactly here is that I'm this memoizing is now done per level. Memoizing dimension A, memoizing dimension B. I have a 2-dimensional caching. Good so far, because I can go in both directions. If I can transform a by function to a queried function, I can add memoizing, and then I can unquery this one to give you back a pure by function. So I can add caching with whatever function you will give me, because I'm transforming this one, adding the memoizing functionality, transforming it back, and give you back this by function. For you, it's no difference, because if I'm going over the memoized function, you have to imply it over 2 levels. This is not nice. So we have to do it in a way that you are going back to this by function. Okay, this is more or less the same. Then I'm creating and unquerying. It's only one step. Reverse. I don't want to go too much in details. You can have this slides, but the main thing is you're going to the current version and you're going back. Theoretical stuff. By the way, you can do it not only on by functions, you can later do it on try functions as well. It looks like this. Clear, huh? It's easy. First dimension, second dimension, third dimension. Okay. And what should I do with this stuff? Having in mind you have to deal with legacy classes. So now you have an implementation, and this class is written during the PhD of your CEO. It is allowed to refactor this class? No. But you have to deal with this, and maybe this is an old one. And then you have a new team that is completely focused on functional stuff. They are building all this new stuff and using by functions and cool. Now we have these 2 worlds, how to bring both worlds together. What you could do is, for example, I have here my legacy class. There is a method with input A and B, and it will give you a string. Okay, and I have something that needs a by function. Okay. I have my legacy class. I can't change the source code. I just get this instance. What I can do is here, I can say from this instance, please give me the method reference of this class method here. Do work A. Int to string. Int to string. Int to string. What that? Who's using this stuff? Okay, for the rest. Why there's no typecast here? Why is no casting? The good thing is, You can map to functions, and the only thing that should fit is input, 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 even with boxing, unboxing, and output, output, output. What we can do now is I can go to my legacy implementation, grabbing the method reference out of it, invoke dynamic and so on stuff is happening now, but I have a by function. With this by function I can do now all my fancy stuff with a new API, so I don't have to change my old stuff. The next thing is, if I'm now adding memoizing here, I would have partially caching on my legacy method. Partially caching of my legacy method, yeah, this one. And I'm not changing the original. So if I'm giving you back later this one, there is no change. I can do it, and I'm not disturbing or destroying something. So it would look like this. I'm grabbing my old instance, I'm grabbing the function out of it, and I start working on my function. Now I can combine old world and new world. Okay? Without changing the old way. What's the nice version of here? Who says A? Who says B? Who says C? Who don't like everything? Sure. Whatever you're choosing, it's something is always not nice. Here you have to write a lot of stuff. Here you can use only this constant thing. Okay, this is fancy, but at least you need a value. You can't say there's no value. So we need something like a definition. The most interesting thing is if you're playing around with if then else and you see it in legacy code, it's mostly you need a broad monitor, because this code is just going through the right side out of the window. But it turned out that all if then else constructs can be transformed to a linear list of decisions. And this is quite easy to read. A, B, C, D, E, and so on. How to make it in core Java. What you need is, you have a case, for example, you say, it is the right time to do something, and then do something. If then else is nothing else. Now it's the right time to do something, brackets on off. Okay? And then you can say, I need a supplier that will give me the yes, I'm now the right one to do something or no. And if I'm the right one, I will give you the value, wrapped, because something could happen. Okay. With this, you can have this match case, a supplier for how to decide it's now time to do something and how to calculate this result. And there's one default in the end. If nothing happened, this will be invoked. So make sure that you have always a result. Okay. To work on this is quite easy, because we have a stream of matches. Check if you are now the right one to do something. If yes, calculate the result after you have the first, otherwise go to the default one. Quite easy. Now, whatever complex tree of if then else is transformed in a linear list of decisions and calculation of a result. And if you're writing this down, it looks like this, no? A, B, C, D, whatever. Do something, or whatever, do nothing. And with static imports, having in mind that you have a result, that means you can immediately, after this result is here, start transforming in your functional world without grabbing the result out. Here, there, even asynchronously. But with static imports, it's a very compact way of this description. I start now with decisions. This is the default one, and then all my cases I want to go through. Now I have pattern matching in Java, and it's just a little bit source code. Okay, I don't want to go too much in detail, but the worst thing here with streams is that mostly a stream is active after I created it. But sometimes I have different ways how to create. I don't know which one. The user selected checkbox, yes, no, and all this stuff. I want to define a stream without starting it. I just want to say, this is a stream based on decisions. And this should be done by maybe interactive, user interface or time or whatever. The solution is quite easy. I need a function that will create on input values a stream. And then I can create these functions. I can start querying and compose and all this stuff, but the stream is only active after apply. Okay. So here it is. I have functions, only the transformations, stateless. I have here values. I'm grabbing 4, I'm adding, and so on. And this one, I think I want to transform. Streams, what's here? Main, okay, this I have. No, I have too many slides. Wait, I will remove this one, otherwise we are just out of time. I think we are just out of our time. So, what I can show you is how to deal with this reactive part, with this complete future, if you have a few minutes more. Otherwise, I would go to the summary based on time. So, who is for the extension with this reactive stuff? Complete future. Half and half. Oh, slowly more. Sorry for this. Okay. So, the observer stuff. If you have all this function, now you can transform functions and scalar and all this stuff. The main thing is an observer. Observer is reactive, called now reactive, but UI development is observer since a long time. What we have is, I have a key and I have something that should happen. So, a consumer. So, it means, what I want to have is, I want to have that if I'm doing something, other parties are informed to do something with this value. And this is quite easily done. I can say, if you have something, give me this result. This is in a concurrent map. And if something is happening, an event is happening, then I'm going through all events and invoking just this function that I will give you as transformations that should be done. After this, I'm done with my observer. So this is the easiest way to build an observer. And what you can do is you can register sending events and you can unregister consumer. So now I have something that I can deal in a programmatic world. I can do it on the fly. But I can remove this one and make only a thing out of it. What I want to do is, I have more or less a registration. A registration is something that holds what I want to do, but gives me the possibility to unregister myself. Otherwise, if I'm only pushing stuff to an observer, I have a memory leak produced. Okay, so far it's more or less a first step. This is if you start writing this stuff by yourself, only to understand what's an observer. But let's see how we can do it. This is only how to use it. We can have the slides. I want to go to this complete future stuff. This is more or less an extended version of an observer. Complete future is not a process, not a thread. It's something like a fiber. In Kotlin you have this coroutines, it's more or less the same. There's a little bit different way of describing this stuff, and the heavy version is an actor. Okay, I have to deal with completion stages. That means, what I'm doing right now is, I'm wrapping different functions, and this is the first thing. Go first functional, then reactive. It's mostly better than first reactive and then try to make some functional stuff. If you have only functions, means you're stateless. Stateless means only transformations. Transformations you can put somewhere, and it could be invoked sometime. So, how to deal with this? It's more or less quite... It's quite easy to say. You have something where it's running on. You define where's the pool, where the work should be done. You have something that will give you values. And you can say asynchronously, this task, this thing that should happen, must be done in this pool. So the transformation and the resource where it's running in. And then you can say, except maybe later if it's really happens, and do something. By the way, don't forget this shutdown. Okay, what I have now, I can describe the resource, I can describe the function. If I'm going first functional, I have these functions already, so I don't have to deal with the state anymore. What happens if you have something like this? Something will give you value A, something will give you value B. You don't know in which order and how long it will take, but you need both for an operation. And with this result, you want to combine in an operation 2 the value C. And you have no clue at what time this value C is coming. And this is the final result. How to implement this with threads? Oh my God, there's a huge amount of work. But based on this observer, what we have here is more or less, I can start this completely futures. Okay, and then I can start combining them. It means if I have step A done, remember this holder and combine with this result, then use this transformation and with this value to create the next one. And this is somehow done. And this you can do again and again and again. Okay. If you're writing this one, this is quite nice because you don't need to know if A or B is the first one. Only if you have both, the transformation will be invoked. Okay, so you can chain all this stuff now. You can decide, okay, what is the right pool to work in. You can change pools, for example. You say this is a pool for waiting for network, this one CPU intensive stuff. And that means that you can deal here with different sources and pools. And the function, the transformation, could be described in a static method in this interface. So you don't have to write them down. You can programmatically create them. Okay. With this, I have done quite a lot of stuff. I have this graph, this tree. I have here with start in pool A, combine then asynchronously in this pool with the next source, using the same with the next source, and then consume this stuff. This is a quite compact version of describing this graph. And now I don't care about in which order the values are coming. The most thing is I have one part that's combining asynchronously the values, and I have the transformation completely separated. So go first functional and then go reactive. But who learned something about core design pattern? And this is the last thing. Design pattern are not bad. Having in mind, I want to have a complete future active after creation. You know it already. I want to define a complete future without starting it. Maybe interactively, I want to have this chain, which resource is used or which source is used. We need a function. What is the price? A function to complete the future. Again, we are back in the functional world. So, what I want to do here is, I have these different transformations. I just wrote them down to make it easier on slides. And I'm combining them. This is what I've done before. But how much of this code is repetitive? A lot. Okay? How to make this more complex? It could be written in a way like this. Have in mind that we are dealing with functions. I would say, define with the first step something and combine it with the next transformation and combine this one with the third transformation and give me the result function. If I have this result function, the complete future is not running. Now I have the value start. Okay. Now I have distributed the invocation and creation of this complete future and the definition based on pure functions. Because the result is a function. Only the description, not exactly what I want to have, describe how to get it. Okay? And if you want to read this one, it's just this piece of code. What design pattern is this? It's a builder. So don't forget what you learned in your object-oriented world if you're going functional. Combine both. Java is a perfect world for this because you have the object-oriented version and you have the functional version. Combine both. Here I'm just using a builder pattern to give the possibility to combine transformations asynchronously without any bigger accidents. This completely future thing here can use every developer in my team. This complete future thing I had before is maybe a little bit complex. Okay? So, combine the object-oriented world, combine the functional world, make the best out of it. Your goal should be something for the developer that's easy to use. Have in mind, if you're going functional, the wording will be more generic, so make sure that you don't have this mismatch with these APIs. Make sure that your inheritance inside your functional interfaces is clear enough that you don't have this overlapping of these methods that we have with interface A and C, you remember maybe. Okay? And all of this stuff is only a little bit core Java. If you want to have this source code, it's on GitHub, and it's just a few kilobyte Java core, plain Java code. And it's running from 8 up to now. No bytecode, nothing. You can set breakpoints, you can debug this stuff, and you have only this, how to make decisions, how to handle exceptions, how to hold value, and how to combine with the reactive world. That's it. And then mostly you can throw away RxJava and all this stuff that will bring a lot of stuff and you don't have bytecode manipulation. Okay? That is more or less what I want to say. I think this is everything. Go to this repository. The best way to keep in contact is follow me on Twitter. If you have questions about this, ask me via Twitter. If you want to play around with this stuff, go to my GitHub repository and so on. And the whole talk is extended in YouTube somewhere. Okay, thanks. So, done. Run.